All right, welcome back, everybody. This is episode 10 in my multi-cloud network architecture series. In this episode, Dana Systems is moving to a new SD-WAN, and after weeks of evaluation, we chose Fortinet. So we have a couple requirements here. Number one, this SD-WAN solution and the integration needs to support BGP integration for dynamic routing and traffic engineering, bidirectional traffic engineering, and we'll go into more depth in that in a moment. Number two, it needs to support IPsec terminations so we can have IPsec end-to-end. And number three, and most importantly for this episode, the entire thing needs to be deployed and repeatable across clouds using a single automation solution. You guys can guess what that solution is going to be, right? It's Terraform. I did a video on Terraform last week. If you haven't watched it, I highly recommend it. Go watch that one. It will blow your mind. Today, I have special guest, Dennis. Dennis is a colleague of mine. He's a systems engineer at Aviatrix, but he also worked at Fortinet for 5 years. And Dennis is going to show us today how this whole integration and automation model works with Aviatrix. I'm really excited to have him on the show. Dennis, thank you very much.
Thank you, Dana, for having me. Excited to be here. I think I've got a very interesting integration that we can show today between our Aviatrix gateways and the FortiGates, the SD-WAN solution that Fortinet provides. And what I've set up here is an environment with a couple of different regions in AWS where we terminate Fortinet's SD-WAN solution, and we then provide transport between the AWS regions we deploy this in. As you mentioned, we want to have a repeatable architecture. So let me just go about what we've got high level in this diagram. And you actually see, if you look at it, it's a very repetitive building block that we got on top. We've got 3 regions that look very similar. Only difference really is that in one region we've deployed our Aviatrix controller that's going to set up all these things. And then in each region, if we zoom in a little bit, we've got our Aviatrix transit layer. We've got our spoke VPCs connected to that with our workloads. And then here right at the bottom, we've got this SD-WAN edge VPC with the FortiGates sitting there that are going to terminate the SD-WAN connectivity that are coming right down here from the branches. So these are branch offices that could sit all around that region. So we've got a region EMEA here. This could be Paris. This could be London, for example. And we are connecting them in back to the FortiGates in the cloud region where we deployed our transit layer. And then these FortiGates are actually set up in a way that they're active-active, that all paths from the branch all the way across our transit gateways, across the transit layer between regions, across our active mesh to our spokes can be used. So what we actually do to make this work, the integration part, is our gateways, the Aviatrix transit gateways, they've got a IPsec tunnel connection back to these FortiGates, these headends that are sitting here in the cloud. And as you can see, we've got a full mesh of tunnels between them. So any gateway can talk to either of the FortiGates. And across these tunnels, we're leveraging BGP to exchange routing information.
Awesome. This is fantastic, Dennis. This is very similar to what we've done in previous videos with other SD-WAN vendors. However, in this video, we're going to automate all of this with Terraform. So this is just so cool, so exciting. So let's get on to doing that.
Yeah, that's right, Dana. So let's look at how we created this repeatable architecture across these different regions and how we automated that deployment, right? So as you already mentioned in the introduction, we're doing infrastructure as code here. We're using Terraform, so we don't have to repeat this. And if we are to deploy a fourth region, for example, and we want to add that, rather than having to go in and build all that stuff manual again, we can take the same code that we set up in a modular fashion and deploy it again. So let me just pull up the code here. Let me just lay out the code real quick. I'm not going to go through all the details, all the modules. But what we've done is basically we've built a modular Terraform repository where if we say we want to deploy a new hub, we basically call a module that's located in our modules VPC region, which I'll show you in a bit. And we submit a bunch of variables to it that we need to define that specific region that we want to deploy. And we do pretty much the same thing in this case, where we also simulate the branches. In the real world, you'll probably have physical offices where you deploy this box. within my demo lab, I am actually deploying the branches as code as well. So I'm doing the same thing. I can have 20 branches if I like, or I can simply say I deploy this in a certain region, for example.
Awesome.
So let me show you the region real quick, because this is the module that we use to deploy our environment multiple times. So we call this module, this VPC region module, 3 times to deploy 3 different hub regions where we terminate that connectivity. And I deploy both the Aviatrix components from here as well as the FortiGates. Some of it is done through our own Terraform provider, the Aviatrix Terraform provider, and some of it uses AWS, for example. So in order to deploy all the gateways that we need in the Aviatrix solution, you can see right here in this Aviatrix Terraform provider, I am deploying the actual VPC that we deploy our transit gateways in right here. Mm-hmm. We've got our transit gateways that we deploy over here with all the details. What's the size of our gateway? What kind of subnet do we want to position this in? Mm-hmm. Which VPC are we referring to deploy this? And this is actually interesting. So for you guys that might not be familiar with Terraform too much, I'm not going to go into the details of the code, but I'm actually referring to what I've just created right here. Mm-hmm. So I don't have to think everything I'm doing. I can just leverage all the attributes I've already created. Mm-hmm. So this is really powerful. And then we go creating the spoke gateways in VPC 1 and 2. And we prepare our connection that we're going to use to the FortiGate later on. So this is the external device connection. If you're in the GUI, if you're doing the transit setup, this is actually step 3 of the transit setup, connect to an external device. Mm-hmm. So basically we provide all the details that we need to build those VPN tunnels with all the BGP peering information. And you can see I'm using variables here to set up different AS numbers for different regions. And that way, this is a very modular approach. We can replicate this 1, 2, 3, or a dozen times if we want to, without having to repeat all the code.
So Dennis, this is fantastic. So what you're showing here is that you're actually going to deploy the entire Aviatrix component, including the transits, the gateways, the spokes, and the gateways in the spoke environments, all of that via Terraform. This isn't touching the Fortinet side yet. So if customers wanted to integrate with the existing Aviatrix transit environment and Aviatrix spoke environment, they could just refer to those environments, right? They don't have to build it from scratch every time, right?
That's right, Dana. That's a great point, actually. So these resources are all built from scratch in this example. Yeah. But if you want to call an existing resource, you can leverage Terraform as well. So you could say, for example, I want to, and in this case, I've got an example of some AWS objects. Mm-hmm. I want to leverage an existing DNS zone to put something in. So I can use Terraform to gather information about that object and then refer to that AWS Route 53 zone pub that I've just called upon here that already exists. And if I go to my actual DNS records that I'm pushing, I can leverage that. So I'm doing that right here. So I'm using that data object that I've created. So if I want to use existing elements, sure, I can just query the Terraform provider, give me the ID of that object, dear Aviatrix controller, and I can then set up the settings against that already existing object.
Yeah, that's truly amazing. This is just so incredible for our customers to have repeatable architectures across multiple clouds, and they can build, they can deconstruct, they can rebuild so easily. Okay, cool. Yeah, let's see how FortiGate gets built up too.
Yeah, so I've actually taken the easy approach here, Dana. Rather than going through the Fortinet Terraform provider, which also is available, I've chosen to bootstrap the configurations because for my purposes, I know what my configuration is going to look like from the get-go. I built that configuration based on templates, and I bootstrap that configuration. If I were to later on modify that configuration or to add on top of that configuration, it will be very useful to start using that FortiOS Terraform provider at that point. Mm-hmm. So let me show you what I've done here. Basically, what I've done is I'm creating S3 buckets on which I create the bootstrap files. And the bootstrap files are actually being generated from a template file. And the file that I just showed you on the screen, let me show that this is actually the template file. This is a FortiOS configuration for some of you that might not have ever seen that before. This is what we're actually putting on the FortiGates. And we are parsing information in here. So I'm using variables here just to parse that configuration. We store this file on an S3 bucket. And then when we launch the FortiGate, also from Terraform code, we just say we want to create an AWS instance. We provide it with all the metadata that it needs to run. So for example, we tell it what FortiOS AMI file we need to use to boot this, so we can even determine which version we're going to run. Again, the instance size, which subnet do we want to deploy this. Details like what is the private IP address, which we set statically in this case because that's easier to set up the tunnels in my scenario. We refer to the AWS buckets that I just mentioned, where it can find the configuration, and that's pretty much it. We then launch it and it can find its way from that point forward. We've got the configuration in there. We've got all the details in there that we need.
This is truly mind-blowing, Dennis. I have to be honest, because not only are you deploying the Aviatrix side and the FortiGate side from the VM side, you're also implementing the configuration via Bootstrap. And so the end user really has to do nothing other than insert the variables.
That's absolutely true, Dana. Yeah.
So cool, so cool.
Okay, so Dana, now that I've shown you a little bit of how we built up this Terraform code, let me show you how I actually leverage that code to deploy this environment. So what I've done is I've committed this code to a GitLab repository, actually. So if I go to my browser real quick here, and I go to GitLab, right there. This code is actually in this GitLab repository. It's got a nice diagram here as well, as you can see. And I can then use Terraform Cloud to ingest this GitLab repository, which I'm doing right here in Terraform Cloud. Okay. This stuff is all free, by the way. If you want to set up GitLab, if you want to set up Terraform Cloud, you can do it all for free. And what I've done here is basically I've created a workspace which is tied into that GitLab repository.
Yep.
So I've got the repository coupled to that Terraform Cloud. So what we now can do is we can say, I want to run this Terraform. I can do the plan, and then after I do the plan, I can actually apply that. So let me show you what that looks like. So this is going to take a couple of minutes here. And once it's done the planning, I'll show you what we can see here. Okay, so as I said, we'll give it a few minutes to execute that plan. And what you can see right now, it's the planning is finished. And if let me just pull this up in full screen so I can show you a little bit of what's happening here. Terraform plan is actually gonna give us an idea of what it's gonna do. And in order to do that, it first needs to refresh the current state. It's gonna query the environment of what its current state is. I wanna know, is there a module tree, Route 53, route entry already? I wanna know if there's the Ubuntu image already deployed. So it's gonna gather the state of the entire environment as it is, and then it's going to plan against that whatever action needs to be taken. So we're going to create gateway peerings. We're going to create IAM instances in AWS. We're going to create the Bootstrap configs. All these things, all these objects are going to get created. The firewall instances with all these attributes.
Tons of stuff.
So this is a lot of stuff. So if you go all the way to the bottom, this is a long list. As you can see, there's a lot of stuff getting created. And if you were to build all these elements by hand, I don't know how long it would take you, but you'd probably be busy a couple of days. And actually at the bottom right here, you can see 268 objects to add. So that's all these individual objects that you see right here. So rather than going through the motions yourself and then repeating again if you have to deploy a new region, you can see how powerful this is to build out your environment.
Yeah.
And so then all we have to do once this planning is finished is basically apply this. So I can say confirm and apply, and it will start deploying the actual architecture. This is going to take, in this case, about 40 minutes for this particular environment. And remember, in these 40 minutes, we're deploying 12 Aviatrix gateways. We're deploying 12 FortiGates. We're deploying 12 Ubuntu server instances. all the routes, all the internet gateways that need to be created, all the things that need to be done. And as I just mentioned, it's probably going to take you days if you have to do this by hand, let alone the fact that it's a very cumbersome process. And it just takes us 40 minutes right now. So this is really powerful
Truly
stuff.
incredible. This is really incredible. Going from days to minutes is just unbelievable. Imagine the amount of time and effort and it's just so crazy. I'm just blown away. And so you can also deconstruct this in a short period of time as well.
I can probably terminate this entire lab in under 15 minutes. I can just simply do a Terraform destroy and it will tear down all that deployed infrastructure again.
So after this is done executing, we're going to run some tests and watch the traffic flow.
Right, Dana, now that I've shown you how that Terraform code actually gets applied, let's go through the environment that we've deployed to see a little bit of how that interaction is actually working. So let me just dive into one of the FortiGates to show you what's happening there. And if you look at this diagram, what I'm going to do is I'm going to log into one of these FortiGates here in the hub. And in this case, I'm going to log into the hub 1A FortiGate. For those of you that's seen the FortiGate, you should feel right at home when you see this. And what we can see and what we can do is really quickly see, for example, the IPsec tunnels that we've created. So as you can see, right on the bottom here, these are the tunnels that actually go to our branches. But on the top right here, we can see we've got 2 tunnels to the transit gateway, to the Aviatrix transit gateway, and to the transit gateway HA. So each of these FortiGates has 2 tunnels, as you can see right here. And then we received the routing over these tunnels, as I already mentioned in the introduction. So you can see right here in the routing monitor, we can see we learn through these interfaces, the Hub 1 TG and the Hub 1 TG HA. Yep. We learn our destinations to our other regions, to our spoke VPCs as well. So all that is right here. And what's really cool about this, compared to if you were to terminate this on native constructs, is our transit layer actually propagates all the BGP information. So if I actually go in here to the CLI and, for example, do a get router info BGP neighbors and then provide the IP address, the neighbor IP address of the Aviatrix Transit Gateway, and I check what routes I receive, yep. I can actually, and let me just enlarge it really quick, I can actually see the full BGP path, right. The AS path for that route.
Awesome.
So you can really do all that traffic engineering
exactly.
that you mentioned.
That's what I need, exactly. I need the bidirectional traffic engineering, which is a big limitation when you terminate any type of SD-WAN on a native construct. You lose all that visibility. It's like you take all your BGP intelligence and you make it dumb. And it just doesn't make sense. We should terminate on an intelligent architecture like Aviatrix. I'm so happy to see this.
Yeah, that's really cool. And so if you take this back into that diagram, we can really influence whether that traffic goes over path A, path B, or both, as well as to the spokes. And over the transit overlay that goes to all our other regions. So really cool stuff. All right, Dana, so I've shown you how we deployed it. I've shown you how the routing information is exchanged, that the tunnels are up, but surely you're going to challenge me to also show that the traffic is actually flowing across this environment. So what I'll do is I'll log into one of these branches. So let me just log into branch 1 here to this instance that we've deployed. This is just a VM instance where we're going to log into server 1, branch 1. Mm-hmm. And let's see whether we can reach some of the destinations on this chart. So let's see if we can reach some resources here in the spokes. So we've got VPC 1.1, we've got server 1.1 here.
Okay. So same region reachability, and then we'll try cross region.
Same region, yeah. So let's start easy, right?
Yep.
So in the same region, you can see straight away, and you can see the latency is quite fine, right? So you can derive this is probably in the same region.
Yep.
So what if we go across regions? So let's say we go to server 2-1. So that's actually sitting in our region 2 here. We've got server 2-1.
Okay.
That means that we also have to cross our transit layer right here between these regions.
Oh, there you go, 200 milliseconds. So that's using our global encrypted transit that we build out in Aviatrix.
Absolutely. So why this is cool and why this integration with Fortinet is so great is we've abstracted away all that complexity of building that global WAN between these regions from the Fortinet SD-WAN solution.
Yeah.
So this is why this is such a powerful integration.
Yep, and we have some intelligence here too, because we can carry the BGP information, like the AS path, across this transit architecture so that these gateways can make intelligent decisions based for best path decision making. So I'm really excited to show that.
Absolutely. So let's see if we can reach some other branch in a different region, right? So let's see if we can reach a server in branch 5, for example. So to show that on the diagram, branch 5 is all the way here in the Americas, and we're coming from EMEA. So we're crossing our transit, going to our America transit that goes straight, direct, not without actually passing through Asia, what the diagram might suggest. So that's a direct connection there. And then we go back here down to the branch.
Yeah, you do what I do. You just show like a back-to-back connection. But honestly, we build a full mesh between our global transit, so it's going to go direct.
Yeah, I just want to make sure that's out there.
Yep.
And you can see it based on the latency, because me actually reaching America takes less latency from Europe than going to Asia. So I'm definitely not going over Asia.
Yeah. Awesome, man. This is so cool.
Yeah, let me just prove to you that this traffic also traversed the actual firewalls. So we should probably, I've enabled some debugging just to show you that this traffic is happening. And you can see right here, we've got from hub 1, this is my SD-WAN interface on the FortiGate where the traffic arrives. We've got this echo request to this, I can tell you this is server 1 -1 because I know the IP plan from the top of my head. And we can see that it's sent this traffic onto our transit gateway. And then at some point we try to reach the second server, and we can actually see that that traffic came back in through a connection from the transit HA gateway. So we can see that traffic is flowing all different paths that are available. And if we look at the hub 1B, we can see part of the traffic is there as well.
Okay, so
and this doesn't matter. We have an active situation.
Right.
The fact that traffic flows asynchronously or asymmetrically between these gateways is fine, even for the FortiGates, because we're actually syncing the sessions between the two FortiGate head ends with FGSP as Fortinet.
So this is fantastic because it allows us to leverage equal cost multipath routing to scale out our throughput further and further.
Absolutely. All paths are active.
All right, awesome. And so the last thing I want to go over is to explain exactly what Aviatrix did for us in this scenario. And really, we went through it in pretty good detail. So number one, we were able to build out an active equal cost multipath architecture so that we could scale out our throughput beyond 2 tunnels. All those firewalls can be active, our gateways can be active. There's no limitation there. In addition to that, we had BGP end-to-end, and so we could leverage traffic engineering in both directions, from the Fortinets up to the Aviatrix gateways, and from the gateways back down to the Fortinets in all regions. And so we can have automatic failover between regions. We can carry the intelligence of BGP end-to-end. We also had encryption from the spoke all the way up to the Fortinet gateways, into the Aviatrix gateways, and into a VPC spoke. Really end-to-end encryption. We got rid of the routing table size limitation. If you terminated any of those IPsec and BGP connections on a native construct, you would hit a routing table limitation. We don't have that problem when you're leveraging Fortinet and Aviatrix together. We also had strategic places in the network to enable source NAT and destination NAT. We could do packet capture, and we could leverage some of our troubleshooting tools like Flight Path because it's leveraging the Aviatrix environment. We don't have any regional connectivity limitations because you can put Aviatrix transit architectures anywhere, in any region, in any cloud. We also had a point of delineation for secure and automated ingress and egress for that SD-WAN traffic. We didn't show it in this video, but we could have inserted another next generation firewall cluster for that north-south traffic pattern. If we had segmentation, we could carry this segmentation end to end. And in another video, I'm going to show you Copilot. It's our visibility and analytics tool. And again, you could leverage that because the traffic is going across the Aviatrix environment, and we can export that telemetry to Copilot for visualizations. And lastly, this whole thing was simplified and repeatable across multiple clouds, multiple regions, using Terraform. Really want to thank Dennis for joining us today. This was just so incredible, and I think a lot of our viewers will find this pretty amazing. Thank you so much, Dennis.
Yeah, no worries, Dana. It was a great pleasure to be here.